Hi, we are Nasty Little Pirates. In this video, we will go over the details of our question generation and question answering system. This is our pipeline for question generation. Given an article, we first use NLTK to split it into sentences. We then identify the coordinating conjunctions in each sentence using spaces dependency tag. We simplify a sentence only if it contains a coordinating conjunction that is connecting two independent clauses, as in example 1. If the conjunction is only connecting words or phrases, as in example 2, we do not simplify the sentence. We also attempted to perform pronoun resolution using Stanford Code NLP. However, the code reference chain generated by the package is often inaccurate and led to some awkward sentences, so we decided to leave it out in the final product. To generate yes/no questions, we first identify the subject and main verb of the sentence through spaces dependency parse. Then, depending on verb tense, we decompose the main verb into a corresponding auxiliary verb followed by the lemma form of the main verb. If the sentence already contains an auxiliary verb, or if the main verb is a be verb, this step will not be performed. Next, we construct the yes/no question by performing subject-auxiliary inversion. For WH questions, we first identify potential answer phrases through named entity tags and part-of-speech tags. Words with NER tags as person, date, or location are answers for who, when, and where questions respectively. We search the pause tags for personal and possessive pronouns to generate more who and whose questions. Furthermore, we look at nouns with no NER tags and determine their question words based on the sense key of the noun in WordNet. For example, a noun that is referring to a person will have a sense key starting with 1:18 in WordNet. After identifying an answer, we check whether the answer is the subject of the sentence. If it is, we simply change the subject to the question words and output the question. Otherwise, we will replace the answer by the corresponding question word, move the question word to the beginning of the sentence, and perform subject-auxiliary inversion to construct an appropriate question. Each constructed question will pass through a simple post-processor to fix capitalization, punctuation, and spacing issues. At the end, we take the pool of generated questions and assign a score for each of them based on their length, vagueness, grammar, and type. Questions containing about 12 words will achieve the highest length score, and questions containing any pronoun will have their vagueness score largely deducted. We also check whether the question contains the subject, verb, and object, and assign grammar score based on that. Also, we give preference to WH questions over yes or no questions.
For question answering part, we break up into those 5 areas. We first pre-process the passage the same way we did in question generation. Then we classify the question into one of those categories. Then we use the BM25 ranking function to find the most relevant sentence of the passage. Negation detection is our solution to answering yes or no questions. We look for syntactic and semantic negations in the sentence to determine whether the answer is yes or no. For syntactic negation, we look for words whose dependency tag is neg. For semantic negation, we look for words whose word-to-fact similarity is high with any word in the antonym set of any word in the question. In the first example, complex is similar to a word in the antonym set of simple, so the answer is a no for the question. In the second example, not is the word with negation dependency tag, so the answer is a no. Of course, when we have multiple negations, every 2 of them will cancel each other out. NP ranking is how we answer what/which question. We look at all the noun phrases of the sentence and then we rank them. Those appear under the dependency tree of the verb of the sentence that we're interested in gets +10. We then look at the voice of the question by examining the dependency tag of the word what or which in the question. Noun phrases having the voice we wanted, aka object or subject, passive or active, gets +3. Those that appear in the question gets -5 since the answer is usually not found in the question. In this example, multiple noun phrases appear in the sentence, but the Old Kingdom is the final answer because it gets the highest score. We use named entity searching to answer who, which, where, how much, and how long questions. It is similar to NP ranking. When we didn't find the named entity that we want, we change the question to a what question and use NP ranking to answer it. Finally, we use clause extraction to answer how and why questions. We look at words with certain dependency tags and take all the words under its dependency tree as the clause. We simply rank the clauses by looking at the percentage of the words that also appear in the question. The clause with the lowest such percentage is the final answer.